Automation cells are made up of several components, primarily the robots and their end effectors, along with parts and fixtures in front of them. These can all be manually located and programmed relative to each other, but if anything changes, everything will need to be updated. A cost-effective option is to include a probe on the robot and a tool setter in front of it, so all aspects of the cell can be measured and located systematically. A hardwired probe can be permanently mounted to the robot, or a wireless radio probe can be dropped off when it is not required. Use of probing can aid setup, locate parts, automate program retrieval, increase local robot accuracy, and provide automatic cell recovery. Probes have been used on CNC machine tools for decades. However, whilst a machine tool has stiff, square Cartesian axes, a robot arm has 6+ joints, so its TCP cannot be corrected for using Cartesian offsets, X, Y, Z, alone. An uncalibrated probe on a robot will have to be set up and programmed in a specific orientation for a specific task, and if anything changes, it will need to be programmed again from scratch. Renishaw have developed an easy-to-use calibration routine using a datum sphere, in which a probe can be defined in 6 degrees of freedom relative to the robot. This means the probe tip is understood in all orientations of the robot in the working volume, greatly simplifying programming and allowing for generic solutions. Each part of a cell is located in a certain position relative to each other. To understand these locations, datum systems are set up, defining the position and orientation of parts, tools and fixtures. These datums can be defined using a simple combination of features such as planes, spheres and cylinders, or by using complex freeform surfaces directly on the parts. Once defined, they can be quickly found using a robot-mounted probe. This means offline programming can be achieved, cell initialization automated, and different sized parts accounted for. Industrial robots have been used for years for the 3D activities, tasks which are dull, dangerous, and dirty. Initially, industrial robot arms were designed to be operationally flexible, so they could offer the ability to run a wide range of tasks. However, though they were designed for generic applications, practically they are often used for one dedicated activity in any given automation cell. Robots are capable of so much more, and if robot accuracy is increased from millimeters to hundreds or even tens of microns, then new applications suddenly become viable. By adding a calibrated RCS probe and a tool setter to an automated cell, localized accuracy can be provided by defining and finding datum systems on tools and parts. This can unlock new applications which require higher degrees of accuracy, such as laser welding, precise assembly of complex parts, cutting, milling, finishing operations, and additive techniques. Overall, calibrated probes and tool setters are cost-effective additions to robot automation cells and can enable true offline programming, making setting up datum systems easy, and can increase local accuracy, opening up many new and exciting applications.